So this talk is, as you no doubt know, a game of theories. And the idea for this talk came from frustrations with all the language wars, mostly. Just, go into a room and say, hey, Python and Ruby, and people explode. And my view is that languages are valuable in and of themselves, and there is no one best language. There is no language to rule them all. You see this a lot in the newbie community too, like, oh, what one language should I learn first? What's the best one? It's like, okay, listen, just start somewhere. So that's kind of the motivation here. So we're going to take a very high-level, kind of rapid-fire view at 6 different languages, what their strengths and weaknesses are, why they were created, and how, like, even their weaknesses are kind of for a purpose, because, like, it goes in line with what the language wants to do anyway. So a little bit about me. My name is Rae Krantz. I work for Tallwave, which is a consultancy out of Phoenix, and I just started there, and I'm full on chugging the Kool-Aid because, like, my director and even my CEO have, like, tweeted out about this talk, and they've been so supportive. And I haven't worked at a company before that is, like, that invested in someone when they, go to conferences and are out in the community. So anyway, they're pushing me forward. I'm sorry. Wow. It's like automatically, well, if that happens again, let me know. So as you can see, we're starting with Ruby. So Ruby was founded by Mats. Wow, I'm sorry. This is gonna be a thing. But anyway, a few companies that use Ruby are, and my notes are over here because technical difficulties. But I'm glad it's a small room. I don't have to feel like I'm putting on a show. But Cover My Meds, which is a company here, they use Ruby on Rails. And also Living Social use Ruby on Rails a lot, so it's out there. It definitely took off in the startup community, and it took off in the startup community largely because of Rails, and then also because the founder, Mats, when he went in to create a programming language, he wanted it to be fun. And he succeeded in that. He looked at Perl, he looked at Python, he wasn't totally satisfied by either of those, and he wanted to make something a little more scripting than Perl, a little more object-oriented than Python. So he made Ruby. And it's funny, everything's an object. It was slightly more object-oriented than Python. So something about this goes in line with, again, why Ruby was created, which is let's let programmers have fun. Let's unleash them to the world and give them the power to make what they will of this language. And by everything being an object, everything can be acted on in the same way. You can change properties of everything in Ruby. Now, where this comes back to bite you, like, yeah, it's fun, freedom, but, oh wait, it doesn't come back to bite you yet. First, as a fun fact, Ruby doesn't have these increment and decrement operators because those operate on variables, and everything's an object. So you can do like plus equals, minus equals, but if you wanna plus stuff, you gotta find a new language. Ruby also has single inheritance. This is how, oh shoot, I forgot to say. Sorry, so we are gonna have some Game of Thrones pictures in here throughout. None of them are strictly spoilerish by themselves. At the end, I am gonna get spoilerish when I do character comparisons, but I'll give you a heads up, so if you haven't seen all the shows and wanna piece out, you won't actually miss valuable information. You can do that. Anyway, so single inheritance, this is how they solve the diamond problem, right? Which is when, oh, you have a class A and then class B and C both, change a function in class A, and then class D loads in both B and C, and then, oh crap, well, which definition do they use? Because they're both defining something in a different way. Ruby says, hey, you can only ever inherit from one other class. So, ta-da! It solves that problem. But it created a whole nother world of hell. So monkey patching is Ruby's bane, and this is one of its biggest weaknesses, especially throughout open source, because it is where you can completely overwrite the definition of a function from a class that you're requiring. So package management in Ruby, they're called gems. That's kind of their package management thing. So you could have, Ruby gem A. In Ruby gem A, Aria, she moves to music when she dances, right? Ruby gem B comes along and says, no. Aria's sword fighting when she dances. Let's completely obliterate all even memory. We don't even know what moving to music is. Doesn't exist anymore. Then C comes along and loads in A and B because it wants the stuff in A, but then it wants the monkey patch that's in B. but then or maybe it just wants a couple other things in B, but then it needs to monkey patch B, what B monkey patched in A. And you can see where this is going to get really bad as different open source projects edit different things at different speeds and things don't stay in line. And then you spend days or weeks or stupid numbers of hours trying to track down where the error actually happened and how to go about fixing it. So it's terrible and horrible. But people in Ruby know that, and they accept it because, again, it goes back to Ruby was created for flexibility, to give the developer the power to make the world they want to make. And this is a side effect of that, but it's one that people in the community accept. Well, maybe not totally accept. People are trying to say, you know, stop monkey patching, you fools, but it's there. So again, yeah, this goes into the flexibility of Ruby. Let's make it fun. Let's give developers the tools they need. So arrays, I'm going to look at my notes. Thanks. Yeah. Here we go. Okay, so I wanted to look at how different languages use arrays and stuff because I recently started learning about like the arrays and linked lists and like specifically how they kind of compile down. So arrays are static, right? Because you can access the variables in them by indices, and so they have like a set length. And if you need to edit an array, you're actually creating a whole new array and copying the old array and then adding your new thing onto it. So that's kind of how arrays work. Whereas linked lists, they're all over the place. Their memory is not necessarily sequential, so you can expand them and unexpand them at will. Super high level definition for people who might not be too familiar. Arrays in Ruby combine a little bit of both of those. They're just kind of like, we want just kind of this flexible thing people can do whatever with. So arrays, when you instantiate an array in Ruby, you automatically have 3 memory spaces, like off the bat, even if you only have 1 or 2 objects in the array. Because again, they want to kind of decrease the number of times that you have to reallocate that memory. And then I think the next jump is like to 20 and then 50 and then on up, and it kind of increases by a set percentage each time. But that's one way Mats was like, hey, we don't want to confuse people with too many options. Just here, have an array, and it kind of does both of these things and go to town. So that was a fun thing. And then another interesting thing about Ruby is they have for loops. You can do a for loop, but all the cool kids, get it? She's freezing. Like all of us are going to be in a couple hours. All the cool kids use x.each, which does the same thing, right? So for I in array, do blah, blah, blah. Array.each, do, blah, blah, blah for each item in it. And that's just kind of a fun little like personality quirk of Ruby, if you will. Their iterators are awesome. They're not necessarily more efficient. They're just fun. Because Ruby likes to be fun. Ruby likes to have fun. Case in point. Pythonists are all, hey, explicit is better than implicit. And Ruby is like, look at this, I made a bong out of a hairdryer. So if you ever get into one of those Python versus Ruby arguments, feel free to pull that one out. But as you know, Python and Ruby are often pitted against each other. So we're going to take this opportunity, now that we've looked at the hell of Ruby's monkey patching, but all of the fun that you can have with it, we're going to jump into Python. So Python, of course, was used at Google, is used. I know they also obviously have Go now and all that. Let's see, Instagram recently did a whole big transition from like Python 2 to Python 3, so it's out there, right? And it's out there when people are typically processing data. That's kind of Python's angle. And it goes along really well with why it was founded in the first place. So the founder, he was working in system administration, and he wanted a better way to do that. And I actually didn't know this about how kind of Python came about, and it was really interesting because Python, that's how Python is used now, right? It's used heavily in the DevOps community. It's used heavily in like Linux, and it's used for this kind of stuff still. So it's really neat that it is still fulfilling its purpose, if you will. And Guido, of course, he looked at a few other languages and wasn't happy with what they were doing, as most languages come about, and wanted a better way to do things. Now, Python has something called the Zen of Python, and it lays out like 15 or so kind of core values of Python. And one of them is pretty is better than ugly. So Python really highly values that their syntax looks good and clean, and you have the spaces matter. You need those 2 spaces there to do an indent so that it knows it's a function. If it was not indented, it would not be a part of that function, and your function would be undefined, and everyone would be confused. So spacing is important because it's easier for humans and also, linters. And then the colon is there just to kind of clarify, hey, yeah, we're gonna give you all the stuff now for this function. Lists and tuples. This is, I feel like almost Python goes against its personality with lists and tuples, because lists and tuples are like basically the same. And that is they implement what you are familiar with as like arrays in other languages. So they're basically the same, but the only difference is that tuples are immutable and lists are mutable. And some people want to say, oh, lists you can only use, everything has to be the same. Oh, and homogeneous. Tuples can be, heterogeneous, and that's not the case. It's not enforced by Python. Like, there are best practices, but you can kind of do what you want. Well, I was kind of, come on, Python, you're supposed to be explicit is better than implicit, and you're a little bit fuzzy here. But they are different in that, one is mutable, one is immutable. So it tries to give them different purposes, at least in as far as that goes. And one of the purposes is in dictionaries. Now, the way Python implements dictionaries is essentially like a hash map or something from another language. And the dictionary keys are immutable. So this is where you could use a tuple as a dictionary key in Python. You could not use a list or anything like that. And again, this kind of goes in line with Python's mission to be efficient. And to be very process-minded. Like, hey, we need immutable keys because that will allow us to process data faster, right? You don't have to worry about what types your keys are. It's always going to be the same. You can figure out what's going on in your dictionary a lot faster that way. I love this about Python. Args and kwargs, mostly because kwargs is fun to say. And I don't know, these guys look funny, so that's why the picture went. There's nothing else to it there. But args and kwargs are, you can feed into a variable number of arguments and keyword arguments into your functions. And arguments are essentially when you feed it into a function, it kind of turns into a list, more or less, that you can iterate through, whereas keyword arguments would turn into something like a dictionary. So that's kind of the difference there. But it's really powerful, and I think it really goes in line with, simple is better than complex. So Python here is kind of giving you a way to do what you want to do, still within the bounds, right? Like, you can't feed anything into an argument if you have a key value pair that has to be a kwargs kind of thing. They have a little bit of guardrails, but mostly they're also trying to give you power to be efficient in the best way possible. And science. So Python is huge in data science, right? And this happened kind of largely because of timing. So Python is an older language than something like Ruby, and around the time when Ruby was created as a language was also the same time that Ruby's NumPy library came about, or NumPy's predecessor. And so that's when Python really took hold in the scientific community, and that has only grown since then. And now it's kind of a chicken and the egg thing, right? Like, NumPy was so awesome and gave so much power to Python scientifically. So now more libraries have been added, and now it's kind of a self-feeding thing. And now the two kind of big competitors are Python and R, right? So I don't know if anyone had the chance to see Matthew Reason's talk. Reasons? Crap. Sorry, guy. But he talked about R, and we were chatting a bit, and he was saying, yeah, R, for someone who comes from the scientific background, they usually prefer R. Someone from the programming background typically prefers Python. So that's why they're kind of battling it out with their different libraries. But this is another piece where I think it really speaks to Python's, again, its personality and its purpose. Like, explicit is better than implicit. Scientists probably like that. Like, they're not, so much about, let's just throw stuff around and see what happens. We'll deal with, monkey patching, no problem. No, they want things a little bit more structured, right? And I don't know how much that had to do with it. Again, NumPy was definitely a driving reason why Python took off, but I like to think it was a little bit of Python's personality too. Another thing is the founder and the core developers on Python are all about keeping kind of the superfluous stuff out of there. Keeping things simple, again, right? Simple, clean, orderly. So if you want a multi-line comment, you use multi-line strings. There is no separate, operator for a multi-line comment. And this is the founder saying, yep, we know, we don't have it. It's fine. There's other stuff. Use that. You'll be good. And another example of this is Python doesn't have case and switch statements. And a lot of people get upset about this. There have been a couple responses from, actually, a core Python developer was saying some people have proposed how to add case and switch to the language, and those proposals have been rejected for various reasons. And they're okay with rejecting them, like they don't feel rushed to implement a case switch because they say, oh, you can use if, elif, else. It's fine. And also like dictionary, mapping and things like that. So those tools are there, and yeah, this is probably a sore spot for some people, right? Python's like, no, we're good. We have tools you can use that basically does this. We're fine. We don't need to force something, and that's kind of their mentality. We don't need to force an implementation that we don't think would be efficient or good to do something that we can already kind of do. So there you go. So one thing, though, where Python falls short, and I need to quote this one now. There's a company called Stream, and as their name implies, they do a lot of data processing. And they said, Python is a great language, but its performance is pretty sluggish for use cases such as serialization, deserialization, ranking, and aggregation. And it was in that blog post where that quote came from, where they talked about their transition into Go and how they replaced some of their Python stuff with Go. So now we're going to talk about Go. Go, as you know, is, or most likely know, has been founded by Google, and they use that heavily. Some companies have been transitioning their, some of their Python stuff into Go as well, as we saw with Stream Story. So it's pretty widely used. Now, Go's main values. They wanted something that was fast, they wanted it to be clean, they wanted it to be easy to write and read, so that distributed teams could work together well and efficiently in Go. And I think they achieved that. We'll get into it. I actually really like Go. It's a cool language. But one thing that made me laugh, though, is that like on the Go website they talk about how like, yeah, when we were looking at making Go, we wanted to make a language that had like the good stuff of some of the languages, of all the languages we liked, but none of the bad stuff. Like, oh, good idea. You're original. No one has ever thought of that before. Let's make one perfect language. But it is really cool. I'll give them that. So the main thing that Go does well is concurrency, and they do that through Go routines. Go routines are Go's concurrent threads. And to start one, you just put Go in front of your function, and now it's on a thread. And that's kind of cool and magical and super simple, right? So they're fulfilling their mission there for sure. Channels are the channels that are within Go routines that can communicate across threads. And to make a channel, it's as simple as that. And then to put stuff in your channel, it's as simple as that. And channels are used to keep threads on the same page as far as information and stuff that everyone's doing. And they also they don't have to use a lock system for like security when they're passing stuff, because they wait like the channel that's sending the message waits until the channel that's receiving the message is ready to receive it, and then they send it. So that's how they kind of keep things, information flowing without getting bogged down. Now, array slices and maps. I wanted to throw this up here too because I thought it was a little bit interesting how Go implements these, and that is, so arrays are actually what a true array should be, right? Like at compile time, it's set, it's immutable, it's not going anywhere. It is what it is. So Go through slices on top of its array object, and slices are more of what you would think of an array from, like Python or Ruby or JavaScript or something. So slices, you can slice and dice and add and append and all that fun stuff, and it's sitting kind of on top of the array. But if you need a true array, it's there as well. So that was pretty cool. And then maps, what did I want to say about maps? They are a dynamically growable associative array. And this is kind of what you would think of. It implements a hash table. But an interesting thing about maps is how they access the data in it. So I'll go ahead and throw both of these up there. But so if you want to access a value from a key in Go, you can throw up one of these. So the top one, you are looking for a variable to assign to I, right? Or looking for a value to assign to your variable I. And OK in that second slot is just saying I want to get a true value back. Like I want this thing to exist. So this piece is pretty useful. You don't have to have the OK. You can just say, I equals, and like normal. But the OK there is used for like error handling, right? You can also, instead of OK, you could have like ERR, error, like I'm expecting an error back. So Go has tried to kind of build in like you state what you're expecting, and if you don't get both, a value and the actual state that you're expecting, then you can handle that. So it gives you these tools to handle those things. And the bottom example is, of course, when an underscore is saying, OK, I just want to make sure the value's there. I don't care if it's there, but I want to make sure it's there. And then with that OK, you're saying I want to make sure I get that true back, that it is there. And if it's there, I'm fine, I'm good, we're moving on. So that is one way that it kind of deals with maps. But I like to call the underscore when variables don't matter. I don't know if anyone's ever seen this picture. It made me funny, so made me laugh. So I wanted to include it. But yeah, so and that's another way, that underscore is another way Go handles memory management. That was another value of theirs as well. They wanted to make sure they weren't hanging on to all these dead variables, right? Because that slows your stuff down, and they wanted to be fast. And that's one way that they do that. Another thing that Go does that's interesting in terms of being maybe less verbose is implicit returns. Like this function will return both A and B. You don't have to say, return AB. It's going to. If you assign a value to a variable, it will be returned in the return statement. So that's fun. You can think of all sorts of things to do that. And another way it controls or helps the developer code well is with imports. It will not let you compile if you don't use all of your imports. So you can't just add a whole bunch of crap and not use it. It makes you use all your crap. And tabs. Oh, right, yes. So tabs versus spaces. Go has decided on tabs. And it enforces this because they use Go format, which it's used all throughout the standard docs, and most people who are in the community, most people like it because when you go to save your Go code, you hit save and Go formats it all, and it's magical. And then everything looks the same, right? Then it's consistent. And so then again, it's easier for another developer to come in and know what's going on because all the code looks the same and you can tell where things are and what's happening there. So things that Go is missing. This is from a survey that Go gave to their kind of developer community. As you can see, it's basically dependency and package management is what they're missing, just said in a few different ways. And that, it's a lot of it is because Go is a relatively new language. I think it was like 2010, 11. It hasn't been around very long, so they're still very much growing. And one thing I did also like about Go is they are hugely invested in their open source community. So this is something they're aware of and working on. And yeah, just go check out their blog. It's got some cool stuff on there. I appreciate all their communication. So you might say, oh, cool, so Go is awesome. It solves all my concurrency needs. But well, maybe it doesn't solve all your concurrency needs. And then I want more concurrency. So what other languages can we look at that have concurrency? Dun, da, da, da. Erlang. So Erlang, and I apologize, that's a little hard to read, but Erlang was created by a telephony company for essentially the problems that telephony industries face. And it wanted to make sure, essentially, if something died, if one process died, none of the other processes would die. They could keep on going without it. And that process would have ways of recovering and getting back online. Because when you're handling hundreds of thousands of phone calls and one server crashes, you can't just have your whole thing go kaput. So that was kind of Erlang's driving mission. Excuse me. And it's dynamically typed because the founders all were used to dynamically typed languages. Fun fact. That's all. But one thing that Joe Armstrong, one of the founders, he made a joke comparing it to Java's write once, run anywhere, and Erlang is write once, run forever, because they're really focusing on that get down to the nuts and bolts, only run what you need to, and make sure it stays up. So that's Erlang's personality. It processes. Oh, I'm sorry, that's a typo. That's embarrassing. Process communication, or no, that's not a typo. Processes communicate with message passing. I'm sorry, I'm actually really sick. So a little bit of like chugging tea, it's fine. But processes communicate with message passing, and this again kind of avoids the need for like a lock scenario. So instead of passing the actual variables across processes, they pass messages, and then the thread that receives that message will take the information in it and know what to do to create the data that that maybe would have been passed in a traditional sense. So it's a cool workaround, and again, it kind of lends to want all of the processes to be as independent as possible, while also obviously communicating with each other. It's error handling. This is neat. So one of the ways it handles errors is, like I've mentioned a couple of times, if a process dies, that process spits up to its host process, hey, I died and here's why I broke. And then the host process can say, okay, go roll over and programmers will figure you out later, but now I know that you died. I need to go start up a new process to take your spot because we got to keep going. So that's one kind of clever way that it handles those edge cases. And another thing, I really like this about Erlang. So it has a bunch of built-in functions for data type checking, and this is because another mainstay of Erlang is that it wants you to know what you're expecting and to explicitly state what you're expecting. And that goes with like errors and everything as well. And so instead of having something like in JavaScript or a lot of languages, you can say type of blank, and then it spits out, oh, this is an object, oh, this is a number, whatever. That's not in Erlang. In Erlang, you have to say, I expect this to be an atom. I expect this to be a binary, and it'll return true or false. But the point is that it fits in line with Erlang's, like, you should know what you're expecting. You should know what you're looking for, and explicitly state that. And another thing is your functions in Erlang can be named the same, sort of, caveat. Like these two functions are completely different because arity, or this how many arguments a function takes, which is that number, it matters and it's part of the function's name. So some 1 and some arity 1 and some arity 2 are completely different functions. They're not the same. They won't run into each other and they're not going to overwrite. And yeah, that's fun. Although sometimes similar to this can lead to fun errors because the arity is also, the type does matter. So you might feed in like, some arity 1 and you feed, which you probably would not do, maybe if you were always adding that to the same number. Anyway, let's say you had to feed in like a string or something there, and you fed in an array. And so then your argument or your error message might just be, oh, some arity 1, you expected an argument and you fed it in an argument and it broke. I'm sorry. Like, what? But I did what you told me to. So some of the type error handling doesn't give you as much information sometimes as you would like. But I will say this about Erlang. I actually had fun. One of the times I had to go in and debug something in Erlang that broke, and I had to read the source code and figure out what it was expecting and why my thing didn't work. Like, it was very clear, and it just made sense. And like I had been programming for like a year at that point, and so I do appreciate that. Like, Erlang gives you what you need and nothing extra, or at least that's its goal. And another aspect of Erlang is kind of built-in recursion, if you will. So these are how most of your functions look, roughly. And they're just looking for, different cases like, hey, if you have like this might work with, say, if you're like iterating through an array or something. And, as long as there's more than one thing in the array, so maybe x is like an array of, length greater than 1, do this expression. And then when it does that expression, it starts back up at the bottom and goes through. And these are essentially like if-else statements, right? And then maybe function y is when there's only one item left in the array, do this expression. So once you've done x enough times to get down to just one item left, then you hit y, you do that expression, then it goes up with its empty array to the top and goes back through. Okay, do I have an array of more than 1? No. Do I have an array of 1? No. And so then this is your catch-all. Like, all right, cool. So we're at the end, and now complete this expression. And that leads to some pretty clever solutions sometimes, and also goes in nicely with Erlang's use of head-tail recursion, which is where your head is the first item, and your tail is everything else. And so you're only ever dealing with 2 pieces of data, and you just feed it back through, right? And when you do what you need to with the head, then you delete it or move it out of the way, and then run back through that list of expressions, right, with your tail. But now your head is a different object, right? Because now it's the first item that was in the original tail. So it's like, it's so fun. give it a try. And then, as you noticed in the expression setup, the function setup, there's no return statement. And it's because everything ends with an expression. Erlang expects that everything will return a value of some kind. So they don't have a return statement because, again, you should just express what you want and then get it, hopefully. So Erlang is neat. And I realized I didn't say too many bad things about it because it's cool. I'm sure there's bad stuff out there. Y'all can talk amongst yourselves. I think the error handling I personally do not love, but does any language really do error handling well? I mean, I think Elm does. That's why people like it. That's what I've heard. Anyway, so you might get through this and you're like, all right, so threads that, never die even if all their neighbors do, that's cool, but I want more, even more. There's this thing called Clojure. Clojure is like super hipster, right? So Clojure was started, the founder, what was his quote? I wrote this down. He wanted it to be robust, practical, and fast, and support multi-threading. And he did pretty well, actually. Spotify is they are transitioning some of their stuff from Python to Clojure to take advantage of some of the stuff in Clojure. But he also really liked Lisp. So let me get another quote from him. His goals were to combine a sweet language, which is Lisp, right, that needs modernized, with functional programming, an industry standard platform, and concurrency. So that's why Clojure runs on the JVM. And this gives it some fun additional things, like Clojure doesn't have some stuff like a date object. It uses Javas, right? So it allows it to be a little bit of a smaller footprint, if you will, because some of that stuff that languages have to create for their libraries, Clojure just pulls from Java and, continues on its merry way. And then it takes a lot of inspiration from Lisp in the syntax and how it manages its data. So the syntax is everything within parentheses is an expression. And there are a couple specific terms. Nope, just a self-contained expression. So this would, set string to hello world. This is just fun. It actually kind of made me think of Yoda, but Yoda's not in Game of Thrones, so I can't say Clojure is Yoda. But this means 1 + 1, right? The operator goes before the arguments, and that's how all expressions are defined in Clojure. So that was fun. And then Clojure makes use also of like vectors along with lists. I'm not even going to try to go into vectors. That's a whole talk by itself. Clojure, it wants to be robust and fast, right? And so it will complete a function in a way that makes the most efficient sense. So with something like conjoin, where you're conjoining an object with another piece of data, it'll complete it in the way that makes the most sense, right? So instead of specifically saying, oh, append, because I want this to go on the end, or pop, because I want it to come off the end, or whatever, and then was it push, like unshift, push, whatever. Those go on different sides of arrays or stuff. Conjoin just does what makes the most sense for the object. So at the top, we have a vector, and it makes the most sense to add stuff onto the end of a vector, so that's what conjoin does. But if you're conjoining with a list, it makes the most sense to put it on the front, so that's what conjoin does, and it just kind of knows that implicitly. And now this parenthesis is not a typo, or parenthesis, apostrophe, is not a typo. Because everything within parentheses is a self-contained expression, when it's not, you have to let Clojure know, hey, don't evaluate this as an expression, it's a thing. It's an object, so that's what that's for, to let Clojure know that, to not expect an expression in that case. And it also has implicit returns with functions as well as with like let statements. And this is a cool thing about Clojure that I don't have time to like fully go into, but if you're super nerdy about languages, look into this a little bit more. So they have these threading orders, and as you can see, so the only difference between these two is that the threading here has a single arrow, and the threading there has a double arrow, and that is the difference. And it tells Clojure in what order to complete the statement. So the threading first puts the, evaluates each thing by putting each sequential argument kind of like at the front or in that second position of the next form. And then the double arrow one puts it on the end. So super cool in a super nerdy way. But again, Clojure is hipster. and we got to move on. This is we're rolling. But it's a really neat thing. My main complaint about Clojure, my only one so far, is all these parentheses. And I know you're Lisp-based, you hipster you, but like, I mean, come on. Like, I can just imagine the linting headaches that would cause. I have enough problems in JavaScript with, you know, what is it, the semicolons and all that kind of stuff. But, you know, he wanted, the founder, again, he wanted a Lisp language, and so he made a Lisp language, and that's what we got. And you know what? I think I could take that. So, because Clojure, there's Clojure, and then there's Clojure script, which is Clojure compiled into JavaScript. And before I wrote this talk, I had never used Clojure before, so I did a lot of this research explicitly for this talk. And it's just cool. Like, I like this. So I think it's going to be one of my, well, this and Go I want to get more into as well. So I hope you guys are also seeing kind of like, these are fun. These are fun to like play with and do things with, and they have power. Like, Clojure is not hugely popular in like, you know, big companies and stuff, but hey, Spotify's using it now, right? Like, it's getting there, and I think it's got a lot to offer. So what if all those parentheses just aren't enough, and I want parentheses, and I also want curly brackets, and I also want semicolons, and I want them to just be on like 5 different lines at once? Let's talk about JavaScript. So JavaScript has always had an identity crisis. So Brandon Eich, when he was under Netscape, and they said, hey, make us a language, and he wanted to make it Lisp-inspired. He really liked Scheme. But then they said, oh, wait, but Java's really popular. You have to make it like Java. And so then we ended up with JavaScript, which really has nothing to do with Java. But you know what's fun? This is just a fun little tidbit. So I started, when I started using TypeScript, I had actually never used Java before. I had read it a few times, like in clean code and stuff, but I've never coded in Java. But when I started using TypeScript, which is JavaScript plus types, I'm looking at it, I'm like, this reminds me of Java, which is weird because I'm not like a Java guru, but this reminds me of Java. And now I kind of wonder, I'm like, oh, I wonder if JavaScript has some like weird Java tendencies that we can't recognize for all the, you know, punctuation, but it's like hiding under there. So give TypeScript, if you are a Java developer, look at TypeScript and just see what you think. It's kind of cool. Anyway, so JavaScript, though, as we all know, is pretty horrible. And I forget if I say this here on the next slide. Yeah, so one of the reasons it was horrible, yes, the rumors you've heard are true. It was written in 10 days. I created the prototype in 10 days, and then the next 6 months were spent implementing it with Netscape, and then it was released to the world. So, yay. And it's funny, in interviews since then, Ike has, you know, he says a lot about how, I think I have this here, well, it's not very, he says it's not very opinionated because I wrote it for beginners. I wanted people to come in and be able to write JavaScript snippets and make their, you know, their web pages interactive, and it totally had a purpose. And maybe it did a little bit. I'll give him that, because he is also very upfront about like, yeah, and I wrote it in 10 days. So that's a part of it as well. So JavaScript is, I don't know, maybe it's like the youngest child in a family of like 10, where it's like, oh, you don't have a lot of structure, but go be free, you know? And let everyone on the internet, you know, just go make friends with everyone. Go make friends with everyone. So it's also not very opinionated, kind of out of necessity too, right? Because when it came around, from the time it was created, there have been browser wars. And this lends itself to a little bit too much flexibility. As anyone who has worked with JavaScript is familiar. But it's an essential part of JavaScript, right? All the browsers are going to render differently. And I talked about this a little bit. He was talking about how, let's see, how did it go? Lost my train of thought. Sorry, let me take a sip of tea. We're good. He's talking about how in the early days, it was actually very worried that Internet Explorer just straight up wasn't going to allow JavaScript. They wanted to do their own thing, right? The Microsoft behemoth. So they were creating different, you know, engines around it, and even thinking like, okay, maybe we could have people like actually download JavaScript. And obviously, Internet Explorer implemented it, sort of, and you know, we moved on. But he realized pretty early on, he's like, JavaScript has unique challenges because like you can't tell someone, here, run this program. It's a Python program, so as part of the installer, we're going to install Python, and now everything will work. No, we don't do that. Everyone has JavaScript, but it's different JavaScript based on whatever browser they're using, and JavaScript doesn't care what your OS is. And so that's why JavaScript has so many weird personality quirks, is because it can't be consistent. Even so, I know we always make fun of Internet Explorer, but excuse me, there is a bug, and I say bug in air quotes because it's not a bug, it's an intentional design in Firefox. Although I guess really the bug is in Chrome and IE because Firefox does it correct, which is if you have an input and you set the value to number and you have trailing zeros after a decimal, because I don't know, maybe you're working with currency, Firefox does not render those. It will not pass those, let you take those up to the DOM. Chrome and Internet Explorer do. So this is a further example, like, you know, Mozilla is quote unquote correct in that, like, yeah, you don't need those zeros, right, for the number, like it knows what it is and they are superfluous and get rid of them. But currency, man, we have to work with that sometimes. So this is just a very small example of how things can be different across browsers, and we all know that, and that's why JavaScript is the wonderful youngest child that it is. And it doesn't have a sleep, and I actually, this is funny, I've never thought about this before, but then I realized, oh yeah, there is no sleep, and it makes perfectly obvious sense, right? Because you can't tell the browser, hey, shut JavaScript down for a few seconds. Like, that's not gonna work. So we have all these things to kind of go around this, right? You know, wait untils and yada yada. And now with like ES6, we have like debounce time and throttle and all these fancy things. JavaScript is getting super, super cool. But yeah, you can't make it sleep. Once it's awake, it's awake. And this, I think, I would assume, is a relic of the 10-day prototyping phase, which is we have an equals equals, or a double equals, but it doesn't match type and value. So 5 double equals a string of 5. That is true, yes. But it's not, right? It's not, like if you're dealing with types. So in JavaScript, again, if you're a JavaScript dev, everyone uses, like, always use triple equals for all time, because then the 5 equals a string of 5 will give you a false and everybody's happy, and 5 equals 5 will give you a true, and again, everybody's happy. But the double equals is still there. Again, you know, it has these leftover vestiges of its quick growing period, and that's one of them. So have fun. I don't know necessarily if it's embraced as much as it's tolerated, but it is a piece of JavaScript. And I wanted to say, oh yeah, so arrays in JavaScript, you can do whatever the hell you want with them. You can add stuff to the beginning, to the end, to the middle, take them out, iterate, whatever, remove, blah, whatever. They're mutable. They're insanely mutable. Objects are mutable. Everything is mutable. Ha. Because again, JavaScript doesn't have like those nice like bumpers maybe that like Python had, or like training wheels. No, it's just like, hey, here, go. Again, one of Ike's founding kind of things, he's like, I wanted beginners to be able to get on the web, copy someone else's JavaScript script, make a couple changes and implement it on their own, and add, you know, more interactivity to the web and make things more fun. So you can do a lot without a lot of rules. Speaking of rules, these, like, JavaScript have some like call, apply, bind, which you can use, like, if a function tells you you have to give it a certain type of an object, and your object isn't in that type, so you can just call an apply on it, and now that function will accept your object, even if it's not the right type, because you can just make magic like that happen in JavaScript. And this is something that really frustrates people, right? There's not a lot of consistency. But if you just embrace the inconsistency and, you know, hang out with it, it makes fun. Oh, whoops, sorry. That is, well, spoiler alert. If you don't want spoilers, now's the time to leave. I wanted to compare languages to wrap everything up to Game of Thrones characters. And I know we didn't actually talk about Lisp by itself, but I feel like Lisp is the true king here. Like, it's puppeting all the other languages and affecting everyone and controlling them. So that's why I went with this. Like, and I didn't realize that about Lisp. That was also something, like, it's in everything. JavaScript is Lisp inspired. Okay, it's everywhere. Literally, because JavaScript is everywhere. So the next one I wanted to figure out is Ruby. Now, I'm not going to stop here, so don't freak out too much, because I know So she has a red ruby around her neck, right? This is kind of obvious. And Ruby on Rails is all about the magic. Ruby's all about, oh, make, your own, destiny. So this like sort of fits, but not really, because she's very serious, right? She's very serious and kind of melancholy, and she's also like wrong all the time. So I was like, okay, who is like magic, but also super chill, like Ruby? Magic, but with beer, right? The drunk priest. This is Thoros of Mir. I guess the picture is a little hard to see, but there's no story so good a drink won't make it better. It's like, that fits. That fits Ruby's thing. So Python. Like, you know what? Okay, so Python has kind of two aspects to it, right? There's 2.7, and then there's 3+. And 2.7 was 2.7 to 3+. It was a very kind of rough split, right? And so I thought 2.7, stoic, follows the rules. Whatever, say what you mean what you say. Ned, good old Ned. But Python 3 is sort of like Ned, but with dragons, like async and stuff. So, Jon Snow. And then Erlang, multi-threading, is kind of like, yeah, you're everywhere all at once. It's fine. And then JavaScript, so many faces. All the faces. And ECMAScript is hiding in there somewhere, right? We know it's there. And then I think next one is, so Clojure is like, when it first comes on the scene, you're like, you're not going to be that big of a deal. But then you realize they're kind of cool, and also they have unbreakable oaths or data structures. So there's Clojure. And then to round it out, so Go is super fast, right? People in here watch the show. You're all the way through. Most recent stuff for the most part. So Go just wants to be super, super fast. And Go is all of Season 7, Need for Speed. So that's what I got. I hope it was useful to you. There's a lot of really interesting things that are cool. I'm told I'm supposed to encourage you to take the survey or give me a survey. Constructive criticisms are very much appreciated. And if you want to chat, let me know. So thank you.